This is the chemistry bonding project. I, Davis Wooden, and my brother Harris Wooden decided to use the podcast format for this project. And this bonding project goes over 3 types of bonds: ionic, covalent, and polar covalent. And all 3 of these bonds follow the octet rule, which states how an atom wants to reach 3 outer valence electrons, or it wants 8 valence electrons in its outermost ring. It can reach this by gaining or subtracting electrons. And these bonds are on a spectrum: ionic on one end, covalent on the other, and polar covalent in the middle. And then go into the first bond. Characteristics of the ionic bond. This bond gives and takes electrons. Traditionally, this bond has high electronegativity, and it takes place usually between a metal and non-metal. And the product of this bond usually has a high melting point, and they're usually brittle and have a crystalline structure, and it disassociates into ions in water. And usually ionic bonds are going to produce salts. It's usually between a halogen it's usually between a non-metal and a metal, and usually between halogens and alkali metals. Alright, I handed my brother to do the next bond. Okay. Sorry. This is the characteristics of covalent bonds. First off, they share electrons. They have a lower electronegativity. They have a lower melting point and electrical conductivity, and are also insoluble in water. And next we have the characteristics of polar covalent bonds, which are between ionic and covalent on the spectrum, and their electrons are shared unequally, and the electron distribution and density is greater around the more electronegative atom. And there's 2 types of these polar covalent bonds, which are very and moderate. So how the spectrum works is you have on the left side of the spectrum, if the total you subtract between so if you have, for example, an alkali metal and a halogen, if you want to find out the electronegativity of the result product, it's minusing one from the other, and then that answer will fit onto the spectrum, and it'll determine the bond. So if you you can do that between any 2 atoms. If the result electronegativity is within 2 and 4, it's an ionic bond. If it's lower than 0.4, it is covalent bond. And if it's less than 2 but greater than 1, it's a very polar covalent bond. And if it's less than 1 but greater than 0.4, it's a moderate polar covalent bond. And that's how the spectrum works. That's how you determine what type of bond is going to take place. And then the examples for each of these bonds: example of ionic, sodium bromide, I think that's how you pronounce it, NaBr. It has a crystalline structure because it's a salt, and it dissolves in water, like most ionic bonds. An example of covalent, phosphorus trichloride, PCl, and then 3. It's a clear liquid used as a gasoline additive, and then electrons are shared throughout the molecule. These two are on the far right side of the periodic table, so you wouldn't expect them to bond, but due to its sharing, they can bond. And then the next example would be polar covalent bonds. And the example is sulfur dioxide, SO2. And then this is used, used to help make sulfuric acid. And it's polar with the oxygen atoms, since this has an unequal electronegativity, and that's why it's polar. It is more polar to the oxygen side, so the oxygen will be the ones attracting more electrons, attracting more bonds in interactions. All right, and then sources for this podcast, I'll just read them out. Kim.libretext.org, byjuice.com, byjus.com, and then the next one, courses.lumenlearning, LUMEN learning.com, thought.co.com. And that'll be all. All right, thank you.